Your calculators with you. I got some extras. I got one more up there if you need one. I definitely need that bad boy today. All right, here's what I'd like you guys to do first. I'm not even going to tell you where this is going to lead into. Can you just sketch on top of your notes here for day 3? Sketch your own circle. Sketch your own circle for me. And draw in, freehand it for me, please. Draw in a radius for that circle. So make a center point for your circle. Make a radius. I have actually 3 different circles up here that I've already done. Here's the question I have for you. How many of those radii could you fit around the circle? So take a look at your radius that you drew. Say you cut it out. How many of them could you put around the circle? And surprise, our answers would all be the same, no matter how big or small you made your circle. Okay? No matter how big or small you made your circle, all of us will fit. Ready? I did one. I did them. I'll take this first. Actually, no, let's take the big one here. So here's my radius. I can fit 1, count them with me here, 2, 3, 4, 5, 6, and change. Right? And all of you, if you measured your radius right now and went around your circle, you'd be able to put 6 radii and a little more around your circle. All right? 6 and a little more. Let me say that one more time. 6 and a little more. 2 days ago, what did we call that distance around the circle? What'd you call it? Circumference. And what was the circumference formula that involved radius? Can everyone please go to their calculator? And what did R represent? Can everyone go to their calculator right now and do 2 pi and find the decimal value of 2 pi? 6 and some change. That's where that formula comes from. You can fit 6 and a little more radii around any circle. Okay? Any circle, you can fit 6 and a little more. Okay? Everyone all right on that? All right, I'm going to take this very slow, even though today it looks like we have not many notes, and we don't. A new type of way to measure an angle. Your whole career, you've always measured an angle in what type of units? That angle is such and such degrees. Absolutely. Well, there is actually a second way you can measure an angle, and it is called radians. All right, it is called radians. Let me first describe to you how a radian is created. All right, a radian is created when the radius and the arc length match each other. All right, I'm just going to do this up here. I do not want you to do this. I just need you guys to focus in. So if my radius length is 1 centimeter, and so is my arc length, 1 centimeter, I've created 1 radian. All right, that angle measures 1 radian, which is something in degrees, which we'll get to in a second how to convert. All right, but it's 1 radian. So let me ask you guys this question, because they tell me I got some enriched kids in here. Let's say this is 6 centimeters, and that's 2 centimeters. How many radians do you think I created there? 1 radian is when they both match. Well, now that's 6 and that's 2. How many radians do you think I just created here? How many more times is 6 than 2? 3. So it's 3 radians I've created. Let me do another one. I know I'm going over the... Let's say my arc length, a little bigger now, is 36 inches, and my radius is 6 inches. That degree measure is 6 radians. So that is how a radian is created. When the arc length and the radius length are the same, 1 radian is created. If they're double each other or triple, okay, it's 3, and in this case, 6. Okay? Will it ever be a decimal? We'll get there. Okay, we'll get there. Baby steps first. Okay, baby steps. So, all the way around the circle's how many degrees? 360 degrees. And how many radii could I put around here? 6 and change, which is 2 pi. I don't want to write 6. What's that number on your calculator? 6 point. Okay, do you want to write that all? Either do I. So instead we write 2 pi. So 360 degrees is the same as 2 pi radians, 6 and change radians. That's one conversion right there. Everybody good? Did you get a haircut too? Looks good. Do it yourself? No. All right, get your money back. All right. It looks good. People are like, oh my God, he complimented somebody, and then I just threw that away. Did I? Yes, I did. Saturday over break, once a month. Once a month. Once a month. What? Actually, maybe I should. You're right. Frankie didn't do his job. Maybe I should get my money back. No. No. Zero facial hair. Sorry. It drives me nuts. Drives me nuts.
Get that handlebar mustache.
All right, we all good here? Anybody else want to chime in on my next styling when I go to the salon instead of the barber, maybe? Okay, here we go. So all I want to work with you today is how do I go from degrees to radians, radian to degrees? How do I get to convert back and forth? Here's your first conversion. Everyone have your formula sheet. Some of these you used last year, some you're going to use this year, and some you're going to use next year. The first one we're going to use is going from degrees to radians. So does everyone see where it says degrees? 1 degree. Everyone see that? So 1 degree is equal to pi over 180 radians. So what we're going to do is when we're given a degree measure, we're going to multiply it by the conversion on the formula sheet, which is pi over 180. We are on I'm going from packet to formula sheet. Okay, so everyone take a look at your formula sheet. Everyone see where I'm getting that pi over 180, where it says 1 degree equals pi over 180. So go ahead, do it real quick, guys. Do pi over 180 in your calculator. Pi over 180. And what are we getting? So there's 0.01745 radians in 1 degree. Less than 1 radian is in a degree. Okay, do you want to write that whole decimal out all the time? Me neither. That's why I put pi over 180. All right, so let's do this officially now. Take 30 degrees and convert it into radians. 30 degrees is how many radians? Well, I'm going to take 30 and multiply it by that conversion, which is pi over 180. And you guys have been telling me all along today, do you want to write that whole decimal out? No. So when you write radians, keep the pi in there. Okay? Keep the pi in there as pi, because you don't want to write down the full decimal. So, no cross. Is there an equal sign between these two? Is there an equal sign? No, so don't cross multiply. It's 30 times pi over 180, and all I am going to ask you guys to do is please reduce 30 over 180. Again, we are keeping the pi there because I do not want to write out that full decimal. Just keep the pi there, it's easier. Anybody 30 over 180? 1/6, right? 1/6 as a fraction. So I can say 1 pi over 6. That is 30 degrees in radians is pi over 6. 30 degrees in radians, pi over 6. Can you turn 45 degrees into a radian measure? I'm not changing anything, guys. I'm going to multiply by the conversion right on the formula sheet. Degrees to radians, pi over 180. Again, I love it if you keep the pi in your answer and reduce that fraction for me. All right, let's start hearing from you guys. 20, what do you got for me? 1 pi over 4. Nice job. Okay, 60. So 60 pi over 180. Is going to be equal to, reduced it, 12, got it reduced. 60 over 180. 12. Pi over 3, thanks, Emma. And finally, 90 degrees as a radian. $15, what do you got for me? Real quickly, just so you see how this all comes together, hopefully now. Remember what we said? 360 equals 2 pi, right? Well, how would you go from 360 to 90? What would I divide 360 by to get to 90? Well, 4, right? So guess what I would divide 2 pi by? 4. What's 2 over 4? There you go, pi over 2, which is what we just found. Okay? All right. I don't want to tell you. How do you think I go from radians to degrees now? Right, it's on the formula sheet now. Now I multiply by the reciprocal, which would be 180 over. And everyone's like, oh, I always forget which one to multiply by, and sometimes they can't figure out the formula sheet. Here's the way I always remember it. If I see a pi there, where's the pi got to go to cancel out? It's got to be on the bottom. So that's how I know to multiply this by 180 over pi instead of the other one we just worked on. All right, so here we go. 7 pi over 6. Multiply it by 180 over pi. And you guys, we just talked about it. What's going to cancel out? The pi's are gone. So I'm left with 7 times 180 all over 6. And I don't know that one off the top of my head. Is there an equal sign? We only cross multiply when there's an equal sign. Now we just do numerator, numerator, denominator times denominator. And how many degrees are in 7 pi over 6 radians? And you ended up with 210? 210 degrees. And if you, hey guys, I say cancel out the pi's, but you could put both fractions right in your calculator in your fraction template, and it's still going to give you 210. Calculator will cancel them out for you. All right, 3 pi over 5. I want to convert that into degrees. I look at my formula sheet. I look at where it says radians to degrees, and it says multiply it by 180 over pi. Again, no cross multiplying. Numerator times numerator, denominator times denominator. And what do we end up with here? 17? 108 degrees. It's the same as 3 pi over 5. All right, 7, hopefully no issue before we get to the big dog, number 8. And that would end up being 5 pi over 3, same as 2. Thank you, sir. Guys, what do you not like about 8? It looks different, because why? Well, why does it look different? It's no pi. Okay, you can still, remember, where's that sucker? Oh, I probably erased it, son of a gun. Stop. Remember today, I had the 36 inches and the 6 inches, and how many radians did that create?
6.
Not 6 pi. So you can have it without the pi. It's okay. The conversion's not going to change. Guess what I'm going to multiply the 3 by? Conversion's not going to change. I don't care if there's a pi there or not. What am I still going to multiply by, Nick? 180 over pi. But guess what's not canceling out now? The pi. So in my calculator, I have to do 3 times, yes, 180 over pi. So don't automatically assume you're going to cancel out the pi's unless there's one given to you. What's this? What do we have? Into degrees? Where did I leave it? Nearest tenth. There we go. Nearest tenth, everybody. So it's about how many degrees? 3 radians. About 171.9. Whoa, whoa, whoa. Easy, kiddos. I know that's the end of the notes, and we're all getting excited because the homework's not that long. Bonus question. You and your groups. 1 radian. How many degrees to the nearest tenth? 1 radian is equal to how many degrees to the nearest tenth? About how many degrees in 1 and only 1 radian? 6? About 57.3. So in 1 radian, there's about 57.3 degrees, everybody. Okay? Questions, comments? All right, you should be able to get through the homework, get out your Chromebook, check it, and be good to go before you leave. And maybe even try out the review problem.